So quiz number 15, practice quiz number 15, says a 600-kilogram roller coaster is moving through a vertical circle of radius 14.0 meters with 275-kilogram passengers on board. So what's our total mass here? 750 kilograms, but I think you're going to find in a minute that the total mass actually doesn't matter, because the only one where you would have to use the total mass would be question A, and you're going to find that the masses cancel in question A. Let's go through this here. Draw the free body diagram. If we're dealing with a minimum speed, we're going to be dealing with the top of the circle. If something's going to fall out of a vertical circle, it's not going to happen at the bottom. It's going to happen at the top, right, where both forces are acting in the same direction. So let's draw the two forces that normally act at the top of the circle. There's the normal force and there's the force of gravity, both acting down. We would say F net is equal to the sum of those forces. But when we're finding the minimum speed, there's something that we can get rid of here to simplify this pretty dramatically, actually. What is it? Yeah, we'll get rid of the normal force there. So this becomes now mv squared over r equals m times g. And there we go. There's where the mass cancels. And that's good news if you're on a roller coaster next to a person that's really, really heavy. You get on a roller coaster and there's a little kid beside you that weighs 80 pounds and you're like, oh, good, that's great. You get on a roller coaster beside a person that's 350 pounds and you're like, oh man, I'm going to fall out of the loop at the top of the circle because this person's so heavy. It doesn't matter. The mass cancels. It doesn't matter whether you're beside the 80-pound person or the 350-pound person. Other than arm space, it doesn't really matter. Mass cancels. Let's sub some numbers in here, guys. V is what we're looking for, the minimum speed at that point. R would be 14.0 meters, and G on the other side would be 9.81. Now, we saw yesterday that technically, when we're at the top of the circle, both of these forces, gravity and the centripetal force, are both negative. So we should, by rights, put negatives in there, but because the negative is in both terms, every term in this equation, what happens to the negatives? Yeah, they cancel. So if you leave the negatives out here, you're still going to get the right answer. Let's cancel those now, actually. Yeah, let's cancel them now. Now, how do we take the 14 over to the other side? Yeah, we multiply it by 14. So we're going to say 9.81 times 14. This is the right-hand side now. And then we're going to, we got to get rid of the square now. Square root it. Second function square root gives us a speed of 11.71921. Yeah, which we're going to round to 3 sig figs, that's right. Some people will look at this and say, well, 75 kilograms is 2 sig figs, but we didn't use that 75 kilograms. Even if you did use it, technically the answer should still be 3 sig figs because you didn't need to use the mass. The mass cancels. The mass is irrelevant. So whether the mass was to 8 significant figures or 1 significant figure, it doesn't really matter if the mass disappears from the equation, if it cancels from the equation. So this is right, 11.7 meters per second. Good. Now, question B, the mass does matter. When we're looking for an apparent weight or a normal force, the mass does matter, but this time we're looking for the normal force on one passenger, 75 kilogram passenger. And we're looking at the bottom of the loop as well. Force of gravity acts down at the bottom of the loop. Which way does the normal force act when we're at the bottom of the loop? Yeah, good, toward the center, so it's acting up. Now be careful, because that normal force should be bigger than the force of gravity. Right? If you're still going in a circle, that normal force will be bigger than gravity. If the force toward the center is smaller than the force outward, it's not going to go in a circle. The only time when gravity would be conceivably bigger than the normal force here would be if you're leaving the circle. You know, you're going around that loop. You're going around that loop and you're leaving the circle. You're exiting the circle. But that's not a circular motion problem anymore, right? If you're exiting the circle. So technically it should be bigger, although if you drew it upwards and drew it smaller, you'd probably still end up getting the right answer to this. F net is equal to the sum of the forces. Can we cancel out, or can we cross off the normal force this time? Yeah, we're solving for that, right? The net force is still mv squared over r. Solving for the normal force. Let's sub some numbers in now. M is 75 kilograms times v. We're talking about the minimum speed here, so let's use the unrounded number, 11.71921. Don't forget to square it. Divide it by r. What was r? 14 meters? 14 meters. And then the force of gravity is 75 times 9.81. What about signs? At the bottom of the circle, gravity acts which way? Down. It acts down, so let's make it negative. Kalia, at the bottom of the circle, the centripetal force here acts which way? The centripetal force, the mv squared over r? Yep. It's always toward the center of the circle. And if we're at the bottom of the circle, the center of the circle is upwards from us. Good. So that's a positive value. We have to be careful there when we're dealing with two things that are different signs. It gets a little bit confusing sometimes. All right, let's get the left side. 75 times 11.719 squared, divided by 14. Let's write that number down. 735.749975, I guess it would be. The normal force, this would be subtract 75 times 9.81. Oh, 735.75, look at that. Oh, that's just going to be 0 then, isn't it? No, it's not at all. It's not even close to 0. How does the 735 go over to the other side? It adds, right? So 735 goes over to the other side by adding, and we're going to say, all right, 735 plus 735 gives me a value of 1471.5 newtons. And when we round that to 3 digits, we get 1.47 times 10 to the 3. Is it 2 digits? Yeah, that's right. Because we did, that's right, because we used the mass of the person this time. So it would be 1.5 times 10 to the 3. You're right. Now, if we were at the top of the circle here, and we were solving for the normal force, the centripetal force would be negative. And then when we brought the 735 over, it would give me 0. It would give me the normal force as 0. But that should make sense because we use the minimum speed, right? If we're solving for the normal force at the minimum speed, what should it be? 0. So it should work out to be 0, and it does work out to be 0 if we were analyzing this at the top of the circle where the centripetal force was negative 735. We're good with that? Watch the little details though, right? Little details. Like the first question, we give you a mass of, 600 and then 275 kilogram passengers. As it turns out, those details don't matter. But when we get on to question B, like the temptation is to use the mass of the roller coaster, or it's to use the total mass, the 750 kilograms. Maybe that's not what we're looking for. We're looking for the normal force on one passenger. Maybe next time you are looking for the normal force on the entire thing, or whatever, like whatever. Maybe not. But just pay attention and read each question carefully and know what you're being asked to find with each question.